Okay, so in lesson 2, we're going to start out with example number 1, and the question asks, how many half miles are in 12 miles? And we've set up our model using a tape diagram or a fraction bar showing 12 complete segments. Now, what the question's really asking us as a division expression is the whole number 12 divided up into halves, or 12 divided by 1/2. And this is different from lesson 1, because in lesson 1, the fraction appeared first, divided by the whole number. Here, our number 12 is being represented by the dividend, and our fraction is our divisor. In lesson 1, it was the other way around. So we kind of have to think here. It's asking us how many half miles are in 12 miles. Well, if we represent this as 1 full mile, and we're being asked how many half miles are in there, obviously that's a half, and that's a half. So for every single mile, there are 2 halves. Therefore, in 2 miles, there will be 4 halves, and then at this point, we can just count by 2s to get our final answer. And we can see that there are 24 halves in 12 miles. What we've essentially done is taken our division problem, 12 divided by a half, and really made it into a multiplication expression, 12 times the denominator, which is 2. This is the reason why we're able to do keep, change, flip in division. I know a lot of the kids are wanting to say, oh, I could just take this number, 12, and multiply it by 2 and get my answer. And what they're essentially doing is keep, change, flip, which is eventually we get to that and we formalize it by the time we get to lesson 4, 7, and 8. So our answer is 24 halves. Now the way that this is different from lesson 1, in lesson 1, the dividend was smaller than the divisor. In lesson 2, the one that we're doing here, the dividend's larger. So 12 is greater than 1/2, whereas in lesson 1, the 1/2 was represented by the dividend, and that was smaller. Now, why this comes into play and why this is important is we learn, comparing lesson 1 and lesson 2, going back to lesson 1. In lesson 1, because the dividend was smaller, less than the divisor, that created an answer that was less than 1. So you're going to get an answer that's a fractional value less than 1. Today, though, in lesson 2, we note now that the dividend is larger than the divisor. And when that happens, our quotient will always, always, always be greater than 1. And that's a good checkpoint, too, when you're doing this, to make sure that, oh, okay, well, my dividend is larger, therefore my answer has to be greater than 1. Let's take it to question number 2. How many quarter hours are in 5 hours? Well, the quarter is going to be 1/4. So what they're asking us is 5 divided by 1/4. Now at this point, you could divide all 5 into fourths if you want. A lot of kids will see that. Or if you just wanted to divide this up and realize that there's 4 quarters per hour, then we would have 8, 12, 16, and 20. We realize that there are 20 quarter hours in 5 hours. And essentially what we've done is 5 times 4 being 20. Okay, the remaining exercises right through page 5 pretty much follow the same strategies, ending with this page, which is what we finished in class today. And then the homework is problem set question 1 only. When we actually get on to the next page starting tomorrow, which is page 6, that's a little bit of a different concept, and we'll cover that in day 2.